Right now I'm going to talk about the acid and base notes is for the back part actually, because the part is takes a little bit time to understand. So the back part talk about we have four different definitions of acid and base. The first one is anhydrous acid. So the definition is it is the acid giving off H plus in water, and they always start with the H at the front. Okay. So for example, nitric acid, hydrochloric acid, sulfuric acid, they always have the H in front. Now, except acetic acid, or acetic acid, sometimes you will see the H at the end, okay, or the this acetate. So those are the exception. But in general, H is always in the front. That's the definition of anhydrous acid. They gives off H plus in water. And then anhydrous base is the base will be giving off hydroxide, OH minus in water. So they always have OH minus at the back. So for example, sodium hydroxide, calcium hydroxide. Now these two are the old version of the acid and base, because from the front of the notes, we can tell ammonia NH3 is also a base, okay? NH3 is also a base, but NH3 do not have hydroxide. So how can I define compound that is a base but they do not have OH minus, such as ammonia, NH3? So then scientists will give another new definition of acid and base to replace these two. The new one is the acid is called Bronsted lauric acid. Now Bronsted lauric acid is H plus donor. H plus donor. That means they donate H plus. So example, if you look it up HNO3, you see that the arrow, and then they donate the H plus. That means the H plus is on the right hand side. Okay, the H plus is on the right hand side. They donate the H plus. Or H2SO4, you see that they donate H plus. Okay, they give H plus as a product. So the H plus is on the right hand side of the arrow. This is a donor. Now Bronsted lauric base, especially replace the old definition anhydrous bases. So they are not talking about giving off OH minus. They say about they are the H plus receiver. So if you look it up, example NH3, right? NH3 is a base, but we cannot use anhydrous base to describe NH3 because they do not have OH. So how can I describe? They will say Bronsted lauric base is the H plus receiver. So for example, NH3 receiver, that means you see that the H plus is on the left hand side of the arrow. So they receive H plus as a reactant and they form an H4 plus ammonia. Or or HSO4 minus, okay? They receive a H plus to form H2SO4, sulfuric acid. So HSO4 minus itself and the NH3 are the Bronsted lauric bases. HNO3 or H2SO4, because they donate H plus, so they are both Bronsted lauric acid.